Yeah, that was pretty much my introductory sentence. So yeah, well, in my day job, so not just here on stage, but in my job, I talk to network operations teams, help them automate their work, be more efficient, be more effective. And today I'm going to do something just a little different and talk about the opposite. So it's a bit of a long story, so let's start at my beginning. How did I get good at this? I got good at this by failing. I brought a prop, which you probably cannot read. This is a hefty study tome called Modern Control Engineering. Once upon a time, I studied aerospace engineering. And this is one of the topics where I failed at. It's very hard. It's called Modern, but the first edition was written in 1970. This particular book is over 2 decades old. I failed at this subject. And that's why I keep this book around, to remind me whenever I've got a feeling that I'm getting really, really smart, that I'm doing something really, really clever, remind me that I'm actually not clever enough to be a proper engineer. But that's one reason to keep it around. The other reason is that in between all the math in here, which to me is, after 20 years, pretty much indecipherable, there's a lot of interesting stuff about, control, systems, system engineering, inputs, outputs, that is also useful in our line of work as network engineers. And so that's what I'm going to do today. I'm going to talk to you about some stuff that I learned from the field of aerospace engineering during my studies and a bit after, that we can apply to our job as network operators, network engineers. So back to my day job. This is one of the tools I use. It's a maturity ladder matrix. It's a tool. Behind this is a whole bunch of questionnaires, checklists, to figure out where in an automation journey an operations team is. And it starts from the initial, the manual work, some initial scripting, automation, all the way up to the end goal of having a fully automated network that basically runs itself. And this matrix, this tool works very well at the lower levels, helping teams get better, get more effective. So when I started talking to teams about automation, most of my customers are at the lower end of the spectrum. I was pretty much at the lower end of the spectrum, and this works really well. Now, an interesting thing starts to happen once you get higher up on the ladder. When there's a certain inflection point where you start to think about how to remove the human from the loop, how to remove any human error, have computer systems run your computer systems, where the magic happens. And at that certain point, some interesting things started to happen. So the elephant in the room here is AI, and I'm not going to talk about AI much. Bert has pretty much got it covered. My personal opinion here, and certainly what you have to keep in mind for the rest of the presentation, AI is basically automation that might be a lot easier to write, harder to debug, but basically it's an automation tool. That's what it does. So, yeah. So I'm going to discuss 3 topics from the field of aerospace engineering about automation. And this is the first one that I like to highlight, because it's an interesting one. We all know there are a lot of problems with the airline industry. They're noisy, they're polluting, it's bad for the environment. So obviously there's a lot of engineering going on to make it better, to make an engine that's more quieter, more efficient, better for everybody. And also, incidentally, fuel costs are one of the big drivers for airline operational costs. So an efficient engine is a great way to save money. Unfortunately, this specific engine is the LEAP 1B engine that's used in the 737 MAX. And unfortunately, it's slightly bigger and heavier than the previous engines used in the Boeing 737 aircraft. So they could use the engine, but they had to move it a bit forward and upward, which had a slight change on where the center of gravity is on an aircraft. And that's quite an important thing. Now, another cost-saving thing is that if you make an entirely different aircraft, you have to retrain all your pilots, which is very, very, very expensive and time-consuming. It's far better to make slight changes to an existing airframe, because you don't have to retrain your pilots, your mechanics, which is saving money for everybody. But how to fit that with those bigger moved engines, changed center of gravity? Well, you can use automation to help you with that. So because the center of gravity was moved, the aircraft has now become unstable. And the Boeing 737 is a very, very, very old, reliable, trusty airframe. It's a decade older than I am, and I'm not young. And it has also always been a very stable, very robust airframe. With the new engine, it has become unstable. So the engineers at Boeing invented a system called MCAS, an automation system, which basically helped the aircraft, whenever it entered an unstable phase, adjust the tail fin to put it back in a stable situation. That means the pilots don't have to even encounter any situation where the aircraft is unstable. Everybody's happy. So the first automation concept that I'd like to introduce is the automation surprise. And an automation surprise is something that happens when you have an automation running in your environment and it does something that the operator does not expect. The operator expects the system to behave in a certain way. The automation causes it to behave in a different way. An automation surprise. And that happened with the MCAS system. At a certain point, MCAS depends on some inputs, and when one of those inputs is wrong, it'll start pushing the aircraft in a more stable course, nose down. And when it's not necessary to do your nose down as an aircraft, you really, really, really don't want it to happen. The pilots did not expect that to happen, so they responded by pulling the nose up, start fighting the system. Because the problem was, they didn't retrain the pilots. So of course the MCAS was a nicely documented system. It was somewhere in the thousands of pages of documentation about the new 737 MAX, which obviously everybody has read, that operates in an aircraft. But when you're not being trained on it, you don't really know it. So the pilots were fighting the automation system, and in the end, the automation system wins. And that results in someone like John Oliver spending 20 minutes to explain very, very, very thoroughly what a shitty company you are. That's not a situation we want to be in. So, how to avoid such an automation surprise? Well, the obvious thing to do is make sure that there's someone paying attention to the system. Be sure that if you have an automation running in your system, that your operator always is keeping an eye on it. And I've got the picture here from Tesla. I don't know if any of you ride a Tesla, but Tesla has this autopilot function, and the autopilot function demands that you, as a driver, pilot, always keep your hands on the steering wheel. And there's absolutely no way to get around it, right? Yeah, okay. Which brings me to my next case. Let me introduce you to a very, very, very nice piece of automation called the auto throttle. And the auto throttle is a an old piece of automation, very reliable, and it's very, very straightforward. What it does, you set a certain altitude and speed, and it'll physically move the aircraft throttles to maintain that speed and altitude. So that's very nice because it has good tactile feedback. You can see and you can feel where the throttles are. Very reliable. And as a human, you can always know what's going on and override it if necessary. Everybody happy? Okay, so concept number 2, automation-induced complacency. Whenever you have an automation running that is clean, reliable, trustworthy, you stop paying attention to it. If there's never an issue with the system, you stop paying attention. The squeaky wheel is the one that gets the oil. And this can happen with the autothrottle. And in fact, it did happen. Incidentally, that's another Boeing 737 story, where the autothrottle, the throttle levers, one of them was blocked. So the autothrottle, the nice clean piece of automation, was physically moving the throttle levers. But unfortunately, in the case of the Srivaya Air Flight 182, it was moving only one of the throttles. And the other one was blocked, resulting in the aircraft setting course to starboard. Which another piece of automation, the autopilot, was compensating by banking the aircraft back. But that increased the airspeed, so they need to move the throttles back further, which made the problem worse. And in the end, the aircraft was banking even more, and banking even more, and banking even more. Okay, at this point, the pilots start noticing that there's something wrong, and they need to take back control. So what they should have done is look at the throttles, because the throttles were set at a different setting. But they didn't, because that system always works. There's no problem at all with throttles. They grabbed the stick and started compensating. And that didn't work, which resulted again in a tragic accident with loss of life. So that's complacency. So how can we avoid such complacency happening? And the question that always comes back is, what if we keep a human in the loop? Let's keep a human in the loop to make all the decisions. Either by removing automations or by having automations that always rely on a human in the loop. And then I come to the third and final case, and that's this situation of automation bias. And automation bias is when your automation system or a computer says something, then the humans have a tendency to believe that it's true, because a computer is more often right than a human is. It's easier to trust a computer than to trust your own senses. And that's really weird if you work with computers a lot, but it's something that really happens. And if you want to hear a horrible story, ask any of the Dutch people here about the benefit scandal, which is also something about automation bias. But that's not my case today. My case today is this one. And this is in here mainly to prove that it's not just Boeing 737s that goes down. But it's also, this is the Everglades crash. This is the incident back in 1972 that set off the entire field of study about automation risks. And in this case, it was one of the first aircraft automation systems. It's called an autopilot. And you set it to a specific course and altitude, and it'll try to maintain that. That's all it does. It's very, very simple mechanical system. And in this specific case, the system was telling the pilots that everything was fine. It was set to 2,000 feet, so that's great altitude. Nothing to worry about. So the pilots were a bit distracted about some other alarms, unrelated. They weren't paying a lot of attention. And at a certain point, there was a discussion in the cockpit. Our altitude's still right. Yeah, the autopilot's on. We're on 2,000 feet, right? Well, wrong. They weren't. And they crashed into the swamp. So, in summary, no, this is not what I want you to take away from this. I don't think this is going to be true. I don't think that we'll automate ourselves into oblivion. That's not going to be true. But there are a couple of things that we need to do as engineers when we're developing automation, and we're developing automation that is sophisticated enough to truly run our systems for us. There are a couple of things we can learn that the aircraft industry learns through investigating all those automation incidents, and we might be able to put them in our line of work. And one of them is the focus on situational awareness. For pilots in a cockpit, it's very, very, very critical that they always know what's going on. For us as engineers, it's always very critical that we know what automations are running in our system. And that's one of the reasons that I always advocate against having a separate automation team and a separate operations team. Because when you have one team writing automation and then throwing them over the wall to the operations team, that's a recipe for disaster. So if you have such a situation, please, please, please try to have your operators write the automation. Or at least train them properly on it. And the other one is don't undervalue the humans. So I got one case in it, which is not a crash or not one with tragic loss of life. Incidentally, this is not a Boeing, not related. But probably AI would not have been able to land this plane. This plane had a catastrophic loss of power, both engines out, and the pilot managed to land it safely on the Hudson. I don't think the Hudson has been classified in the AI model as a proper landing surface. So probably AI would not have been able to do it and would have tried to reach an airfield and failed. We don't know. So let me summarize this in paraphrasing a famous Dutch slogan. It's okay to automate, but please be aware of what you're doing.
Thank you, Robin. I can imagine there are a few questions. Maybe people are now confused. What should I do? Should I automate? Should I not automate?
Well, let me start with two disclaimers. One is I have oversimplified a lot of the aircraft incidents for the case of narrative. So don't pin me on that. I forgot the second one.
You oversimplified.
Oh, yeah. No, and if you have any questions to ask about AI, I have just given my personal opinion on it, and any questions are properly addressed to Bert Hubert. Thank you.
I see that at the microphone we have somebody who is, well, the master of oversimplification, Mr. Peter Lexis.
So they tell me. What are the signs of having automated too much?
What are the signs of having automation too much? I think that whenever you have an automation running in your system that you don't know is there, then that's a red flag. And it's hard to know if there's an automation that's not there. But let me turn it around. At any point, when you're responsible for a system, you should know whatever automations are running on the system.
And if you're not, then you either need to read the documentation or write the documentation, I guess.
If not, you're not really in control. And that's also not just automation, but if you're having a network and you don't know how it works and you're responsible for its day-to-day operation, figure out how it works.
Hi. My question is about automation bias. Basically, how do we avoid it?
Yeah, that's a very good one. How do you avoid any biases? That's just more a psychological question than a technical question, I'm afraid. I think being aware of that is there is the first step. And always be critical of your own reactions, your own thought processes. And that's easy to say and hard to do, but there's no silver bullet here.
Yeah, but that's not really a recipe, right?
Yeah. But But I think that's true for any biases. There's no solution for any biases. The only thing you can do is try to be aware of them and act on that awareness.
Okay, I'll leave it like that. Thanks.
That's all I can do for you, sorry.
Thank you again, Robin.